Pharmaceutical measurement, or metrology. In this supplemental video, I will demonstrate some basic calculations involving the interconversion between units, the apothecary to avoirdupois units, and vice versa, and either apothecary or avoirdupois units to metric units, and vice versa. I will also present the computations applying your knowledge of percentage of error to the aliquot method of weighing and measuring and least quantity method of measurement. Avoirdupois and apothecary units. Question number 1. How many 2 fluid ounce bottles of cough syrup can be obtained from 5 gallons of the cough syrup? In this particular item, the first thing that we have to determine is the number of fluid ounces equivalent to 5 gallons. Remember that in converting your number of gallons to fluid ounces, we can perform dimensional analysis. 1 gallon is equivalent to 4 quarts. 1 quart is equivalent to 2 pints. 1 pint is equivalent to 16 fluid ounces. By multiplying all the numbers in this particular solution path, we will get 640 fluid ounces. That is the equivalent of the 5 gallons. Also, you will see in your table that 1 gallon is equivalent to 128 fluid ounces. Simply multiply 5 by 128 and you will get the same answer, 640 fluid ounces. Because we have 640 fluid ounces of the cough syrup, we simply divide this by the volume that is contained in each bottle of cough syrup, and that is 2 fluid ounce per bottle. This will give us 320 bottles. Similarly, you can perform dimensional analysis. 640 fluid ounces, which is the equivalent of 5 gallons, then multiply it by the inverse of 2 fluid ounces per bottle. In other words, in each bottle there are 2 fluid ounces. We cancel the fluid ounces and what remains is the number of bottles. Avoirdupois and apothecary units. Question number 2. How many 1 over 400 grain tablets of nitroglycerin can a manufacturer prepare from a quantity of a trituration of nitroglycerin that contains 1 over 8 ounce of the drug? In this particular item, we know that each tablet contains 1 over 400 grain. Now, we also know that we have the raw material of nitroglycerin that is 1 over 8 ounce. In order for us to get our answer for this problem, we will first convert 1 over 8 ounce to grains. Take note that there are 16 avoirdupois ounces in 1 pound, and 1 pound is equivalent to 7,000 grains. That being said, in each ounce, there are 437.5 grains. So we will use that conversion factor in order for us to convert 1/8 ounce to grains. We cancel the ounce. What is left is the number of grains. Take note that at this point, you are not allowed to round off any values, but in the meantime, I will write the answer to 4 decimal places. However, in my calculator, I will be using the exact answer. Next, we know that one tablet contains 1 over 400 of a grain. We are asked to determine how many tablets X are we going to get from 54.6875 grains, which is 1/8 of an ounce. We cross multiply this number, or we simply multiply both expressions by 54.6875, then we will get the value for X. X is equal to 21,875 tablets. Interconversion between units. Question number 1. A physician advises an adult patient to take a children's tablet, 81 milligrams of aspirin per tablet, daily as a precaution against heart attack. Instead, the patient decides to cut 5-grain aspirin tablets into dosage units. How many doses could be contained or obtained from each 5-grain tablet? I will be presenting to you several methods by which you can compute or solve this problem. Remember that each tablet contains 81 milligrams of aspirin. First, we will convert this number of milligrams to grains using our conversion factor, which is 1 grain equivalent to 65 milligrams. And this will be equal to 1.2462 grain. This is the amount of aspirin per dose that needs to be taken by the patient. Now, if we have 5 grains of aspirin in each tablet, we can divide this by 1.2462 grains, which is the number of grains that needs to be taken by the patient. This will give us 4 doses. We can also perform dimensional analysis. We are asked to determine how many doses will be given by 5 grain of aspirin. Now we will convert grain into milligrams using the conversion factor that we used before. Next, we know that 1 dose of the patient is equivalent to 81 milligrams. We then cancel these units leaving us only with doses in our final answer. And when we multiply 5 by 65 and divide the product by 81, we get 4 doses. We can also perform ratio and proportion in solving for this problem. Remember that one dose of the drug is equivalent to 81 milligrams of aspirin. We are asked to determine how many doses X are there in 5 grains of aspirin tablet. Now we will convert 5 grains to milligrams in order to cancel the milligrams on the other side of the proportion. We cancel grains, we cancel milligrams, and then we multiply the other expression by 5 and 65. We get the answer X equals 4 doses. In all of these methods, all of the answers are 4 doses. Interconversion between units. Question number 2. Peak body stores of digoxin should be maintained at 8 to 12 micrograms per kilogram of body weight for optimum effect. Express these values in nanograms per pound. In this kind of problem, we will try to convert first 8 micrograms per kilogram of body weight to nanograms per pound, and then we will then convert 12 micrograms per kilogram of body weight to nanograms per pound. In this kind of problem, simply set up your equation like this: 8 micrograms per kilogram, just put 1 kilogram or just put a quantity 1 in order for you to easily convert the denominator to whatever numerical value it is equivalent to in pounds. Remember that remember remember that 1 microgram is equivalent to 1000 nanograms. 1 microgram is 1 times 10 to the negative 6 of a gram, while 1 nanogram is equal to 1 times 10 to the negative 9 of a gram. Next, remember that 1 kilogram is equivalent to 2.2 pounds. You can continuously compute the numerator and the denominator, and that will give you 3,636.4 nanograms per pound. Next, we will do the same for 12 micrograms per kilogram of body weight. We multiply this by 1,000 nanograms per 1 microgram, and this one by 2.2 pounds per kilogram. This will give us the answer 5,454.6 nanogram per pound. Percentage of error, aliquot method, and least weighable quantity method of measurement. Question number 1. In preparing a certain ointment, a pharmacist used 28.35 grams of zinc oxide instead of the 31.1 grams called for. Calculate the percentage error on the basis of the desired quantity. Remember that in this kind of formulation, we need 31.1 grams of zinc oxide. But instead of using 31.1 grams, the pharmacist only used 28.35 grams of zinc oxide. Therefore, we can calculate the error in the measurement of the pharmacist. The error is simply the absolute value of the difference between the two values, 31.1 grams and 28.35 grams. This will be equivalent to 2.75 grams. Next, we can calculate now the percentage of error incurred by the pharmacist. Percentage error is simply the error divided by the quantity desired times 100. The error is 2.75 grams. The quantity that is desired is 31.1. Again, take note that 31.1 grams of zinc oxide are called for. So that is our quantity desired. Then we multiply this by 100. We get the percentage error that is 8.8%. Question number 2. We can apply our knowledge of the percentage of error in calculating for the smallest quantity that will provide us with the most accurate measurement using our balance. If 20 milligrams of a drug substance are needed to fill a prescription, explain how you would obtain this amount of drug with an accuracy of plus or minus 5% using a balance with a sensitivity requirement of 6 milligrams. Use lactose as a diluent. So aside from determining the smallest quantity that is accurately determined using our balance, we will also determine how we are going to prepare for the diluted medication, which we are going to weigh to give us the amount of drug that is needed to fill the prescription. The first step in solving this problem is to determine the smallest quantity. The smallest quantity is equal to the sensitivity requirement, which is equal to 6 milligrams, divided by the percentage of error that must not be exceeded, and that is 5%. Then we multiply this by 100%. Take note that if you don't convert the 5% to its decimal equivalent, then we should multiply this by 100 in order for us to cancel the unit percentage. This will be equivalent to 120 milligrams. Now, there are two methods that we can apply in order for us to come up with the weight of the substance that is necessary to give us 20 milligrams of the drug substance that will be needed to fill the prescription. One of the easiest methods to perform is the least quantity method. In the least quantity method, basically, we want to ensure that the mixture of the diluent and the drug that you're going to weigh will be the least weighable quantity. In that sense, what we will do next is we will get the multiplier from the smallest quantity, which is 120 milligrams, and the number of milligrams that are needed in the prescription. 120 milligrams divided by 20 milligrams equals 6. This is the number of times that we will dilute our medication. Now, take note that the smallest quantity that is weighable using the balance with a sensitivity requirement of 6 milligrams and an accuracy of 5% is 120 milligrams. So, we will multiply the least quantity, 120 milligrams, by the multiplier that we determined based on the amount of the drug that needs to be weighed. 120 milligrams times 6, this will be equal to 720 milligrams. This is the amount of the diluent, which is lactose, and the drug. Next, in order for us to determine the amount of the mixture of diluent and drug that will give us 20 milligrams of the drug, we will just perform ratio and proportion. Remember that we can only measure 120 milligrams of the drug because this is the least weighable quantity in our balance. And we are going to prepare 720 milligrams of the diluent with the drug, containing the 120 milligrams of the drug. If we are to get only 20 milligrams of the drug from the mixture, what will be the amount X of the mixture that we'll need to take? By cross multiplying, we can get the value of X, and that is equivalent to 120 milligrams, which is basically the least quantity measurable using our balance. This 120 milligrams represents now the diluent and the drug, and there are 20 milligrams of the drug in this mixture. The rest of it, 100 milligrams, are your diluent. To prepare the 720 milligrams of the mixture, we will simply subtract 700, we will only subtract 120 milligrams from 720 milligrams. 120 milligrams are the weight of your drug, and 720 milligrams represent the diluent with the drug. This will be equal to 600 milligrams of diluent that needs to be mixed with 120 milligrams of the drug to produce the 720 milligrams of the mixture of diluent plus drug. Take note that in this particular method, we have to ensure that there is no quantity that is below 120 milligrams. Using our balance, with a sensitivity requirement of 6 milligrams and an accuracy of measurement required of 5%, the least weighable quantity, whether it be the drug, the diluent, or the mixture of the drug and the diluent, should be 120 milligrams and above. So let's check each of them. We will be weighing 120 milligrams of the drug, and then we will add 600 milligrams of the diluent to this amount of the drug to come up with 720 milligrams of the diluent and the drug. The 720 milligrams of the diluent and the drug contains 120 milligrams of the drug. In order for us to get 20 milligrams of the drug, we will have to weigh 120 milligrams of the diluent and the drug mixture. None of those quantities are below 120 milligrams, which is the least weighable quantity. That is one method for us to determine the amount of the drug and the amount of the diluent necessary to give us 20 milligrams of the drug substance that will fill the prescription. Another method is the aliquot method. Another method that can be used to solve this problem is through the aliquot method of weighing and measuring. We will again begin by determining the smallest quantity weighable in our balance with a sensitivity requirement of 6 milligrams and the desired accuracy of 5%. Again, our answer will be 120 milligrams. What this means is that we can choose any value or any amount of the drug or the diluent greater than 120 milligrams. Let's suppose that I would like to weigh 200 milligrams of the drug. Just like what we did before, determine the multiplier based on the original amount of the drug that you need to weigh. We need to weigh 20 milligrams of the drug, and if I will be weighing 200 milligrams of the drug, my mixture will have to be 10 times more potent than that of the original drug unless I dilute it 10 times as well. So 10 is the number of times of dilution that is to be made. Next, I will multiply 200 milligrams by 10. In this expression, 200 milligrams is the quantity of my drug, and I multiply it by 10 so that I will be able to determine the amount of the mixture that I need to prepare by adding my diluent. So I will be having 2000 milligrams of the mixture containing the diluent and the drug. Next, I will perform ratio and proportion because in my 2000 milligrams of the mixture, I have 200 milligrams of the drug. I can get an amount X of the mixture that will give me 20 milligrams of the drug. And this will give me a value that is 200 milligrams of the diluent and the mixture and the drug in the mixture. Because I have 20 milligrams of the drug in this mixture, the rest 120 milligrams are my diluent. To be able to determine the amount of the diluent that will be added to 200 milligrams of the drug, I will simply subtract 200 milligrams from 2000 milligrams, and that will be equal to 1800 milligrams of the diluent. Therefore, the answer to this problem is this. Weigh 200 milligrams of the drug, add 1800 milligrams of lactose as the diluent. Mix the drug and the diluent to make 2000 milligrams of the mixture containing the diluent and the drug. And then take 200 milligrams of the mixture to give you 20 milligrams of the drug substance that will be needed to prepare the prescription. Now, can 1,500 milligrams of the mixture containing diluent and drug be used when 200 milligrams of the drug will be weighed? Let us find out. Let us suppose that I will be weighing 200 milligrams of the drug. And instead of preparing 2000 milligrams of the drug diluent mixture, I will only be preparing 1500 milligrams of the mixture containing the diluent and the drug. Now, take note that it is necessary that all the quantities that need to be weighed in the balance are greater than 120 milligrams, which is the smallest quantity that is to be weighed using our balance. 200 milligrams fits that description. The only problem is when the aliquot or the fraction of the mixture that you're going to take will be less than 120 milligrams if we reduce the amount of the mixture. Let's see. In this particular example, we can again perform ratio and proportion to determine the amount of the mixture that will give me 20 milligrams of the drug. This will give me 150 milligrams of the drug diluent mixture. 120 milligrams is still greater than 120 milligrams. That means it is possible for me to take 200 milligrams of the drug and then add sufficient amount of diluent to make 1,500 milligrams of the mixture. The next thing that I will do is I will compute for the amount of the diluent that is needed to prepare the mixture. So I will just subtract 200 milligrams from 1,500 milligrams, and this will be equal to 1,300 milligrams. Is still greater than 120 milligrams. So the procedure is possible. Now, let's go back to 150 milligrams. The 150 milligram mixture of diluent and drug contains, in essence, 20 milligrams of the drug and 130 milligrams of the diluent. Therefore, my answer here would be take 200 milligrams of the drug, add 1,300 milligrams of lactose as diluent, mix the two intimately to prepare 1,500 milligrams of the mixture, take 150 milligrams of the mixture as your aliquot. This aliquot will contain 20 milligrams of the drug. That is the aliquot method of weighing. Now let us apply either the aliquot method or the least quantity method in volume measurements. Question number 3. A prescription calls for 0.5 milliliter of hydrochloric acid using a 10 milliliter graduate calibrated from 2 to 10 milliliters in 1 milliliter divisions. Explain how you would obtain the desired quantity of hydrochloric acid by aliquot method. In this case, we don't really have to calculate or compute the smallest quantity, but we will just examine what are given in the problem. We want to make a certain solution containing 0.5 milliliter of hydrochloric acid using a 10 milliliter graduate, but the 10 milliliter graduate contains will only have the following graduations from 2 to 10 milliliters in 1 milliliter divisions. That is what you are seeing on the picture on the left side. The least volume that is measurable in this graduated cylinder is 2 ml, and we only have 1 ml intervals until 10 milliliters. Therefore, the smallest quantity measurable is 2 milliliters. Anything below 2 milliliters will not be possible in this using this particular graduated cylinder. That is why what we are going to do is we will divide 2 ml by 0.4 ml, the desired quantity of hydrochloric acid. And this will give us a multiplier of 4. This means that if we are going to measure 2 milliliters of hydrochloric acid, we have to dilute it 4 times so that a quantity will give us 0.5 milliliters of hydrochloric acid. So 2 milliliters times 4 gives us 8 milliliters. 2 milliliters here is the volume of hydrochloric acid. And then, since our multiplier is 4, 8 milliliters here is the volume of the mixture containing the diluent, which is water, and hydrochloric acid. Now, in order for us to determine the volume of the mixture or the solution that will give us zero point 0.5 milliliters of hydrochloric acid, we will again perform ratio and proportion. The amount of the mixture that will give zero point 0.5 milliliters of hydrochloric acid is 2 ml. Since my mixture is 8 ml in volume, I will subtract 2 ml from it in order to get the amount of the diluent that is needed to prepare the solution. So I have 6 milliliters. Take note that all of the volumes here are units of 1 or 1. They There are no quantities which are a fraction of a milliliter. Take note that the sensitivity requirement of our graduated cylinder is 1 milliliter. So there can be no value here that is less than 2 or any fraction of a whole unit of milliliter. So in order to prepare a prescription that calls for zero point 0.5 milliliter of hydrochloric acid using the 10 milliliter graduate, calibrated from 2 to 10 milliliters in 1 milliliter divisions, here's what I am going to do. Measure 2 ml of hydrochloric acid. Then, to 6 ml of water, add the 2 ml of hydrochloric acid to make 8 milliliters of the solution of hydrochloric acid. Next, take 2 milliliters of the solution that will give you zero point 0.5 milliliter of hydrochloric acid. That ends our short supplementary video on pharmaceutical measurement. Good luck!